Hello and hi everyone. Today I am going to start the chapter Trigonometry, which is in Standard 10's portion. Today we'll cover two topics, the introduction and the trigonometric ratios. First of all, let's talk about a right angled triangle. What do you mean by a right angled triangle? A right angled triangle, as you can see in the picture in the slide, is a triangle in which one angle is equal to 90 degree and the other angles are complementary. The side opposite to the right angle is known as hypotenuse. As you can see in the picture, AC is the hypotenuse. The other two sides are known as legs or base and altitude. AB and AC are base and altitude respectively in the picture. After this, let us talk about Pythagoras Theorem. Both these topics are recapitulation of Standard 9. We have already studied about right angle triangle and Pythagoras Theorem in Standard 9. So you all know what is Pythagoras Theorem. When you look at the triangle, a right angle triangle, there are three sides named as hypotenuse, base and altitude. In any right triangle, the area of the square whose side is the hypotenuse is equal to the sum of the areas of the square whose sides are the two legs. For example, we can write the equation as AC square is equal to AB square plus BC square. Okay, that is hypotenuse square is equal to your base square plus altitude square. Now let us talk about our topic, that is trigonometry. What do you mean by trigonometry actually? Trigonometry is the branch of mathematics that studies triangles and the relationship between their sides and the angles between these sides. Okay, so as you can look at in the picture, you can see a right angle triangle ABC, okay, right angle at C. So when you talk about any two sides, and when you're talking about the angle which is formed in between them, then that relation or the study of that relation is called trigonometry. Now let us see what is the meaning of the word trigonometry. Trigonometry has been derived from the Greek words tri, which means three, gon, which means three sides, and metron, which means measure. So measure of the three sides of the triangle is called trigonometry. Let us go to the next slide. In this slide, you can see the picture of a right angled triangle. Okay, right angled at B, and there is another angle drawn over here, which is angle A. Now, how do you call this angle A, or how do you define this angle A with respect to different ratios? When I talk about angle A, the side which is just opposite to it, that is your side BC, is called the perpendicular, and the platform on which angle A is formed is called the adjacent side or the base, and the third side which connects your angle A to the vertex C, that side is called hypotenuse. Okay, so this is very important to know which side is termed as what, because when you have to find the angles, this will be very important. Now let us have some fun. We know that in trigonometry there are 6 basic signs. Okay, that is sin theta, cos theta, tan theta, cosec, cot and sec. Okay, now how to remember the angles and their ratios? So there is a mnemonic, or you can say a simple statement, through which you can remember what are the ratios of these different angles. Okay, so let us start. Some people have sin theta is equal to perpendicular by hypotenuse, curly brown hair, cos theta is equal to base by hypotenuse, till painted black, tan theta is equal to perpendicular by base. Through this table or through this statement, you will remember all the three ratios, okay, the thetas with all the three ratios, and you can also remember the other three. Those are cosec theta, sec theta and cot theta, because they are simply the reciprocals of sine, cos and tan. Okay, so we in the detail about this relationship we'll study in the next slides, which is coming. Now let us talk about trigonometric ratios. Let us consider a triangle. As you can see in the next slide, we have a triangle. Here angle A is an acute angle. Note the position of side BC with respect to A. We will call the side opposite to angle A. AC is the hypotenuse of the right angle triangle and the side AB is the part of angle A. So we call it as a side adjacent to angle A. Okay. The trigonometric ratio of angle A in right angle ABC are defined as follows. Sine of angle A is equal to side opposite to angle A by hypotenuse. Cos of angle A is equal to side adjacent to angle A by hypotenuse, and tan of angle A is equal to side opposite to angle A by side adjacent to angle A. Okay, so accordingly we have given the name BC by AC, AB by AC and BC by AB. You can relate the ratios with this figure, so it will be very clear, more clear to you. Now talking about the other three angles, okay, cosec, sec and cot. As you can see, they are the reciprocals of the previous three angles. So they are h by, that is hypotenuse by perpendicular, hypotenuse by base and base by perpendicular. The ratios defined above are abbreviated as sin A, cos A, tan A, cosec A, sec A and cot A respectively. Note that the ratios cos, cosec, sec and cot A are respectively the reciprocals of sin A, cos A and tan A. Also observe that tan A is equal to sin A by cos A and cot A is just the reciprocal, that is cos A by sin A. So how do we get into or derive this, come to this conclusion? So let us see this in our next slide over here. So I have just shown a small derivation so that you are clear with this topic, tan A's derivation. So let us see here how tan theta is equal to sin by cos theta. In the solution you can see, since sin theta just now we studied that it is equal to your perpendicular by hypotenuse. So if I substitute makes P as my subject of the formula, I get sin theta into h is equal to my P. This will be my first equation. Go to the next equation, cos theta is equal to base by hypotenuse. So if I make B as a subject of formula, so cos theta into h again is my second equation. Now tan theta is equal to perpendicular by base. So substituting the values of perpendicular and base, I write sin theta into h by cos theta into h. As you can see, h, both the places your hypotenuse gets cancelled and you simply get the ratio tan theta is equal to sin theta by cos theta. Okay, I hope this is clear to you all. Now, as I was talking to you about angle A, now this picture shows when angle A is shifted to angle C. If I talk about angle C, what happens? Now when I am talking about angle C, my hypotenuse is constant, it remains in the same position, it does not change. But since my angle has changed from A to C, so now my side AB will act as the opposite side to it, so it will be acting as my perpendicular, and the side which is adjacent to it will act as my base, and hypotenuse remains in the same position. So this was all about we have to study about in the first chapter. Okay, so we have sums based on this. So let us do few examples so that you are familiar with the calculation part of the sums. How do we do it? So let us try with an example. Given tan A is equal to 4 by 3, find the other trigonometric ratios of angle A. Solution. Let us first draw a right triangle ABC. Now we know that tan A is equal to BC by AB. Okay, that is 4 by 3, opposite by adjacent. Therefore, to find the hypotenuse, we have to use the Pythagoras theorem. So AC square is equal to AB square plus BC square. So 4 square plus 3 square is equal to 25. So 25 root will give you 5 centimeter. So your hypotenuse is 5. So now I have all the three ratios with me, that is my perpendicular, base and hypotenuse. So I can simply answer all my questions here now. Sin A is equal to BC by AB. Just look at the figure, the green triangle which is being formed here, which is 4 by 5. And cos A is equal to AB by AC, again 3 by 5. Okay, therefore my cot A is equal to 3 by 4, cosec A is equal to 5 by 4, and sec A is equal to 5 by 3. Because in the question it was asked to find all other trigonometric ratios, so one you know, the other 5 you have to calculate. Let us move to the second question. You can see a triangle again. In the triangle ABC, right angled at B, AB is 24, BC is 7. Determine sine A, cos A, and sine C and cos C. Okay, so here we are talking about two different angles, angle A and angle C. So let us see how we will do this. Again, since if I am talking about angle A or C, the first thing which I need to find is I have to find the hypotenuse. So use the Pythagoras theorem and find the hypotenuse. So you know h square is equal to b square plus p square. So in the same way I find 24 square plus 7 square, root over it, I get AC as 25. Root over 625 is 25. So I get AC as my 25. Now sine A is equal to perpendicular by hypotenuse. So this is sine A. So opposite to it is my perpendicular, that is BC by AC. So 7 by 25. Cos A is AB by AC, that is 24 by 25. Sine C, when I talk about sine C, my perpendicular changes. My perpendicular is in this case AB. So perpendicular hypotenuse, that is 24 by 25. Cos C is equal to BC by AC, which is 7 by 25. Okay, let us do one more example here. In triangle OPQ, right angled at P, OP is equal to 7 cm and OQ minus PQ is equal to 1 cm. Determine the values of sine Q and cos Q. In triangle OPQ, OQ square is equal to OP square plus PQ square. Okay, so just one side is given and the other two sides ka difference is given to you. So instead of OQ square, I am going to write 1 plus OP square. I'll substitute the value OP square plus PQ square. Next, I'll open it and I'll use the formula A plus B whole square. So I'll get A square B square plus 2AB, that is 1 plus OP square plus 2PQ, which is equal to again OP square plus PQ square. I have PQ square in both the sides, that is LHS and RHS, so it gets cancelled. So I am left with 1 plus 2PQ is equal to 7 square. So when you substitute the value, you get PQ as 24 and OQ as 1 plus PQ, which is equal to 24 plus 1, 25. So your sine Q is 7 by 25 and your cos Q is 24 by 25. Thank you for today, and that's all.